Welcome everyone to the live interactive session number 9 of the course Mechanics of Fiber Reinforced Polymer Composite Structure. Today I am going to discuss some of the sample problems for the assignment number 9. I am the TA for this course. My name is Ananya Mandal. So the first question is that for a 090 symmetric graphite epoxy laminate subjected to only NX, which one of the following is true? So the options are A. 0-degree lamina will fail first in longitudinal tensile mode. Option B. 90-degree lamina will fail first in longitudinal tensile mode. Option C. 90-degree lamina will fail first in transverse tensile mode. Or option D. 0-degree lamina will fail first in transverse tensile mode. So now in the question, they're saying there is a laminate of 090 symmetry, that is 090-90 in this way, aligned like this. And this graphite epoxy laminate is subjected to only NX, that is in only, you can say in X direction. So we will consider that for the 0-degree lamina, the X direction is the longitudinal direction. So loading is only in this direction. Now for 0-degree, this loading is parallel to the direction of the fiber. So that will give it, that will bear the most strength. So it is longitudinal. When the loading is in NX direction for the 90-degree, it will be in the transverse direction because in 90-degree, the force is perpendicular to the direction of the fiber alignment. Now, in this way, whenever you are having this laminate, you are stretching it in such a way here that for the 0-degree lamina, the force will be bared by the fibers. But for the 90-degree, it won't be bared by the fibers because it is transverse to 90. So in this condition, the probability of the laminate to fail first will be the one which has which can bear lower loading. So 90-degree in the transfer direction will be the one which will be able to bear the loading the least. Hence, option C will be the answer, that the 90-degree lamina will fail first in transverse tensile mode. Because when we are putting the load in NX, it is becoming which is longitudinal to 0-degree but transverse to 90-degree, and that will cause the first failure, as transverse tensile strength is always lesser than the longitudinal. So the option C will be the correct one. Next question is that two laminates with identical dimensions are made from same glass epoxy lamina with same lamina thickness but with stocking sequence 0 plus 45 minus 45 0 symmetric and 0 0 plus 45 minus 45 symmetric are subjected to same axial tensile load. So which of the following is true? So in this question, they are saying that there are two laminates which has the same kind of laminas, but their stocking sequence is different. So in the first one, the stocking sequence is 0 plus 45 minus 45 0, and the second one is 0 0 plus 45 minus 45. Now they are saying if they are subject to the same axial tensile load, which of the following is true? Now when they are talking about a load on a laminate, the first thing we think about is the equation Nx equal to A and epsilon naught plus B K. So the K here is the curvature, B, then there is B matrix, then there is A matrix and the mid-plane strain. Now as both of these laminates are symmetric, so the B matrix will be equal to 0. So we will remove that term. So now this tensile load is directly proportional to the A matrix and the mid-plane strain. So this is the equation that we will get, Nx Ny Nxy equal to A matrix into the mid-plane strains. Mid-plane strains. Now for that we will need the A matrix. Okay. So it is said that they are both subject to the same exact load. So Nx Ny Nxy value will be same. Only thing might be different will be the A matrix. But then A matrix equation is this. So the A matrix depends on the reduced stiffness matrix of each lamina and the thickness of each lamina. Now all these lamina, the thickness will be same. So K minus Zk minus 1 is same for all the laminas, and the Q matrix, the reduced stiffness matrix values will be also same, because even though the sequencing is different, the layers that are used are of the same angles. So when we will combine, we will do the summation of the stiffness matrix and their thickness. The value that will be the A matrix for both this talking sequence will be same. Now if A matrix is same, the load is same, then the mid plane strains will also be same. So that's why the option A is the true one, that mid surface strains in both the sequence will be equal. So whenever we are talking about a load is subjected and we have to find the mid surface strain, the first thing is we will need the A matrix, and to find the A matrix, this is the equation. Next question is, that is 090 plus 45 minus 45 symmetric laminate is subjected to only NX at NY, and the stresses at the mid of top 0 degree ply was found to be sigma x equal to 30 megapascal, sigma y equal to 15 megapascal, and tau xy equal to 0. If the same NX and NY is applied to another laminate made from same lamina but with the stocking sequence 090 plus 45 minus 45 3 symmetric, so that the number of laminae is increased to 3 times, the stresses in megapascal at the mid of top 0 degree ply will be. So it is same kind of question we have tackled last class also. So here the stocking sequence is increasing 3 times. As you can see, it is symmetric and it is 3 symmetric. So increase in the stocking sequence by number only changes the A matrix. And it is said the load is remained as same. So like the previous question, we have to first see, as there is no curvature and the B matrix will be equal to 0 because there is symmetry. So only equation will be left, the load equal to A matrix into mid plane strains. Now the mid plane strains will be equal to the inverse of A matrix multiplied by the load. And to find the A matrix, this is the equation. As the number of stocking laminas becoming 3 times, so the value of the all the values in the coefficients of the A matrix will also become 3 times. So as A matrix will become 3 times, the strain value will become 1/3. So since the thickness is increased by 3 times, the values of elements of A matrix will be 3 times. Hence for same Nx and Ny, the strains will be 1/3, and hence stresses will also be 1/3. So now we know that the stresses value will be 1/3. So we will do 1/3 of the sigma x and sigma y value. So we will get the value for the 3 times increased length, thickness will be 1/3 of the initial stress. So option C will be the correct one. And stresses and strain, they are dependent on the your stiffness matrix. Now if the stiffness matrix remains same, then the way stresses will increase or decrease, the strains will also increase and decrease. That means the strain and stresses are directly proportional. So if the strain will be 1/3, the stresses will also be 1/3, and that's how we can solve this question. Next question is that the reduced stiffness matrix for a unidirectional graphite epoxy lamina is given. This reduced stiffness matrix is given to us. And the strength parameters for the unidirectional graphite epoxy lamina are the sigma 1 tensile ultimate is 1500 megapascal, sigma C1 ultimate is 1200 megapascal, sigma T2 ultimate is 40 megapascal, sigma C2 is ultimate is 250 megapascal, and tau 12 ultimate is 70 megapascal. So these are the limits, the strength parameters of this lamina. So the thickness of the lamina is 0.1 mm. So the question related to this common information is that if a 090 symmetric graphite epoxy laminate is subjected to an in-plane load of Nx equal to 100 Newton per meter, the mid-surface normal strain induced along x direction epsilon x naught is, and we have to find the value in micrometer per meter. Now in this question, the first thing they are given is the reduced stiffness matrix of a graphite epoxy lamina. So we will consider this stiffness reduced stiffness matrix will be for a 0 degree graphite epoxy lamina. Now in the whole laminate we have 0, 90, 90, 0. It is 090 symmetric, so it will be 0, 90, 90 as 0 with the thickness as 0.1 for each lamina. So total thickness will be 0.4 mm. Now last class also we discussed that if the for 0 degree we are considering 0 degree and 90 degree, there are equations to convert the reduced stiffness metric according to angle. But the easiest to convert one for 0 degree angle to 90 degree angle is that the Q bar 11 and Q bar 22 will get interchanged. So from that we get the reduced stiffness metric for 90 degree also. So now we have reduced stiffness metrics for both 0 and 90. Now it's asked in the question that for this laminate, a in-plane load of Nx 100 Newton per meter is given and we have to find the mid-surface normal strain induced in x direction. So first thing to notice is it is symmetric matrix. So B matrix will be equal to 0. No curvature is also given. No moment will also given. So only relation left is the load equal to the A matrix into the mid-plane strain. So for that equation, we will need the A matrix. So from the equation that we already studied before, this is the equation to find the A matrix. So we will get the value of the A matrix. That will be, as there are two 0 degree and two 90 degree laminas, so we are multiplying here by 2. Here it is 2. This is the reduced stiffness matrix of 0 degree into the thickness. And then we have to take care of the units. Plus two 90 degree laminas are there. So 2 into the reduced stiffness matrix of the 90 degree angle into the thickness, and we have to take care of the units. So from that we will get the A matrix. So first step is A matrix. Now this A matrix relates the load to the mid-plane strain. So load value is given Nx equal to 100 Newton per meter. So we will consider other loads are equal to 0. So Nx value given are Ny and Nxy value is equal to 0, equal to the A matrix into the mid-plane strain. Now this will give you a relation algebraic equations, two algebraic equations which will relate this epsilon x and epsilon y naught as gamma xy naught will be also equal to 0 because it is 090, so there is no shear strain there. So considering that, we will get equations with respect to epsilon x and epsilon y naught. So with this, we have two equations. So two equations and two variables. From these, to solving this equation, we can get the value of epsilon x naught and epsilon y naught. And here in the question, they have asked to find the mid-surface normal strain induced along x direction, that is epsilon x naught. So from solving these two equations, we will get the value of epsilon x naught. Okay. So it was a direct calculation. We know the relation between load, the A matrix and the mid-plane strain. So from that they directly asked to find the mid-surface normal strain, so we could get that. Now the next question is, for the same given data, it is said that if a 090 symmetric graphite epoxy laminate is subjected to only NX, what will be the first ply failure load using maximum stress criteria in Newton per millimeter? So this is a continuation from the last question. So in this question they are saying with that Nx we have to find the first ply failure load. So considering the Nx value is equal to 100 Newton per meter, we already know the mid-plane strain by solving this equation 1 and 2. So these equations we solved, we got the epsilon x naught and epsilon y naught, and gamma xy will be equal to 0, and the curvature value, the K matrix, is equal to 0. So we have to convert this mid-plane strains to the global strains. So global strain of each ply can be found from this equation. Epsilon xy and gamma xy for any ply is equal to the mid-plane strain plus the thickness of that lamina and the curvature. Now as we know the curvature value is not given, so we are considering as 0. So we will put all these values 0. So from that we see the mid-plane strain is equal to the global strain of each ply. So it simplifies it further. Now the global stresses at the mid of each ply will be obtained as the stresses equal to the reduced stiffness matrix of each ply multiplied by the strain of each ply. Okay, so this is the initial equations that we use, the relation between stress and strain by using the reduced stiffness matrix. The Q matrix. Now, for solving to find the stresses, what we need? The reduced stiffness matrix and the global strain. Global strain values we got from last question, that will be equal to the mid-plane strain, and the reduced stiffness matrix is already given in the question. This is for 0 degree and 90 degree we already know how to get. From these two things, you can get the stresses in all the plies. So here you can see for the ply 0 degree, you got the value of sigma x, sigma y and tau xy. For 90 you also got. And similarly for 90 and 0, it will be the same and it is symmetric. So we got what will be the stresses at each lamina. So these are your global stresses. Now we have to convert these global stresses to local stresses, because the ultimate values you can see, they are not given in terms of x, y, z. They are given in terms of the particle matrix, the material axis, that is 1, 2 for the whole for the given angles. So to convert the global stresses to mid-plane strain, we will use the transforming matrix. So the T matrix is already, we have already studied, like sir has already taught how the what is the transforming matrix, and for 90 degree the transforming matrix is like this. So we will convert our global global stresses to local stresses by using this equation. Now we got the local stresses. Now we can compare it with the ultimate stress. So to compare it, we got the sigma 1, sigma 2 and tau 1, 2 for 0 and 90 degree angle. This is the matrix for that. And now we will compare it with what is the ultimate value given, so that we can see which ply will fail first. So for the 0 degree lamina, sigma 1 value is this and sigma 2 value is this. And tau 1, 2 value is 0 for both of them, as there is no shear. So we will put like that. From that we can get the stress ratio. So stress ratio is nothing but the sigma value you get divided by the ultimate value. So here the stress ratio 1, that is 1 in the direction of longitude. So you will do 4.76 into 10 to the power 5 divided by 1500 into 10 to the power 6. So from that you will get the stress ratio as 0.000318. Similarly, you will find the stress ratio for all the sigma values. So sigma 2 value will also get, which will be 6467.9 divided by, for the 2 it is divided by 40 into 10 to the power 6. From that the stress ratio you will get 0.000162. Okay, so we are here taking the tensile strength only, not the compressive strength, because we know the load is in tensile. So we will only compare the tensile one here. If in the question it is said that there is a compressive stress, then we will compare it with the compressive stress. But here we are, first thing we are considering, and this is not compressive, this is tensile. So we are only dividing it with respect to the tensile one. Okay, so from this we will get the stress ratio. Now, how to know which one which will be the first one to fail is the one which will have higher stress ratio. So for the ply number 1, that is for the 0 degree, you can see this value is higher than the other one. That means the stress in the one direction, that is the longitudinal direction, is the one which will fail first, as the stress ratio is higher. So failure mode here will be in direction 1, that is the longitudinal tensile mode of failure. Now for the ply 2, which is 90 degree, again sigma 1, sigma 2 value is given, and we can find out the stress ratios 1 and 2 in longitudinal and transverse direction. So from that, this is the value which is the highest one, and it is in direction 2, that is the transverse direction. So we will say the failure first will be in the transverse direction, because this value is highest. So in failure mode is in 2 transverse direction, that is transverse tensile mode of failure. Now, what will be the overall failure? The overall failure we can say is the ply which has the highest stress ratio. So, from all these values, you can see this is the highest one. So, from that we can conclude that ply with the 90-degree angle will be the one which will first fail in the transverse direction. So, that we can conclude from the stress ratio. Now, in the question they have asked the first ply failure load. So, to find the first ply failure load, we have to divide the stress ratio from the given load. That is, Nx will be equal to 100 divided by the stress ratio of the one which will fail first, and from that we will get the first ply failure load. So this value is kind of like a unitary method, which says that if the stress if the stress beared by the laminate in SR sigma 2, that is this value, will be related to the ultimate value. So for comparing that, how much load this lamina can bear when there is a load of 100. That means that if you are giving a load of 23,625 Pascal to this lamina, then the ultimate value you get is 40 megapascal. So for when you will get a given load of 100 Newton, Newton per meter, what will the ultimate load that can be that can this that lamina can withstand? So that we can get by dividing the load which is given to that lamina divided by its stress ratio. So from that you can get the value. So this is a very lengthy question. So there are many steps. So the first thing always is to see what will be the relation between the loads, moments and the ABBT matrix. From that you can get the, uh, if you are given the load, you can get the strain value, and from the strain value by using the stiffness matrix, you will get the stresses. And then you have to change your stresses from the global axis to the principal axis so that you can compare it with the ultimate values. And then for each lamina, you have to like create this table. It is better if here there are only four with two different angles. If you have more angle, you have to create this kind of table which will give the sigma value of all the angle laminas, and then compare it with the ultimate values to find which one will be the first one to fail. So next question is, for the same given data, what is the value of A26 in the ABBT matrix of a 090 symmetric graphite epoxy laminate? So here it is a very simple one. After doing all this calculation, this is very simple. We just need to find the A matrix. So we already know the equation to find A matrix. By solving this, you will get the final A matrix, this one. And we know the notations of all the coefficients of the A matrix. So they have asked A26. So this is the A26 value, which is equal to 0 here. The next question is that the transformed compliance matrix of an angle lamina is given. So, the equations that are used for transforming a compliance matrix for an angle lamina is already given in the question, and the thermal expansion coefficients for an angle lamina related to that of a unidirectional lamina are this. So, already in the question you are given two things, that is one, how to transform a compliance matrix for an angle lamina, and the second is the thermal expansion coefficient of angle lamina related to that of unidirectional lamina. Now it is given that the longitudinal and transverse coefficients of thermal expansion for a unidirectional carbon epoxy lamina are alpha 1 equal to 0.8 into 10 to the power minus 6 meter per degree centigrade, and alpha 2 equal to 40 into 10 to the power minus 6 meter per degree centigrade respectively. And the coefficients of the compliance matrix are, so S11 equal to 0.00625 gigapascal, S22 0.0625 gigapascal inverse, S12 equal to minus 0.001875 gigapascal inverse, S16, S26 equal to 0, and S6 is equal to zero point 0.2 gigapascal inverse. So if a 45-degree carbon epoxy lamina restrained along Y direction is cooled down from 120 degree to 70 degree centigrade, the normal stress induced in megapascal along y direction is. So the scenario is such that you got a lamina, it is made up of carbon epoxy, and the carbon fibers are applied at an angle of 45 degrees. Now this lamina is restrained in y direction. So it can only expand in x direction. So in y direction, the expansion is equal to 0. So the epsilon value will be also equal to 0 in the y direction. That is the strain in y direction we have to consider 0. Only strain will be we can calculate in the x direction. Now there are two things. One, there will be because of to find the stresses, first we need the compliance matrix. As a compliance matrix, you can see is the relation between the strain equal to compliance matrix multiplied by stress. So strain we are given the value that in y direction it will be equal to 0 because it is restrained, and the sigma x and sigma tau xy value is equal to 0 because if there is any expansion in x direction, the stresses will be equal to 0 and the stress will be only loaded in the y direction. Plus, there is a change in the epsilon because of the temperature. So for that, for temperature, we are already given the coefficients of thermal expansion. So the relation here will be the strain equal to the reduced compliance matrix multiplied by the stresses plus the thermal coefficient multiplied by delta T. So putting all the values, considering epsilon y is equal to 0, so and the stress in x direction equal to 0 and tau xy also equal to 0. Only stress that can be there will be in y direction. Plus the thermal expansion values multiplied by delta T. So from this matrix representation, we can take one equation, this middle equation, which will relate the strain in y direction with the coefficients of the reduced stiffness matrix, the stresses and the thermal coefficient and delta T. So that equation you will get epsilon y equal to 0 equal to S12 into sigma x plus S22 into sigma y plus S26 into tau xy plus alpha y into del t. So this is the equation. This is one equation we can get which will give the relation between the stress in y direction. As in the question they have already only asked but that there is a normal stress induced along y direction. That's why anything in stress in x direction we are considering at 0. So we will get this equation. When we will simplify it, we will get this relationship which will give the sigma y is equal to minus alpha y del t by S22 bar. So we got what we needed. We needed to find the normal stress induced in y direction, that is sigma y. This will be equal to minus alpha y del t by S22 bar. So we got the relation. Now we have to solve and find all these values to get the value of sigma y. So first thing, we already know delta t. Delta t is 120 degree minus 70 degree. So that will be your 50 degree. So delta t is known. Now S22 bar. So already this equation is given in the question, the transform compliance matrix for angle lamina. So we only need to find this S22 bar value. For that S11, S12, S66 and S22 values are already given in the question. We will put those values, we will get the value of S22 bar. So that's what is done here and we get the S22 bar value. Got one value, another value, we need alpha y. Now alpha values given to us is in material axis, that is 1 and 2. We have to change it into global axis. For changing it to global axis, we have to multiply it with the transforming matrix. So for a transforming matrix of 45 degree looks like this. So when we will multiply it with the principal material axis values, we will get the global axis values. So from that we will get the global axis values of alpha x, alpha y and alpha xy. So from this we will get the value of alpha y. Now putting these two values here, we can finally get the value of sigma y. So this is the answer. So all the conditions are already given here in the question. So first you will see that it is restrained in y direction. So the strain will be equal to 0, and they are only asking for stress in y direction. So we will consider other all stresses equal to 0. So we can get a direct relation and simplified relation here by considering this middle portion where strain is already equal to 0. So from this relation, when we will get the value of all these terms, we can get the final stress value. The last question is that the longitudinal and transverse coefficients of thermal expansion of a unidirectional graphite epoxy lamina are alpha 1 equal to zero point 0.8 into 10 to the power minus 6 meter per meter degree Celsius and alpha 2 equal to 40 into 10 to the power minus 6 meter per meter degree Celsius respectively. If a 0 degree graphite epoxy lamina is fully restrained and experiences a temperature change of delta T equal to 60 degrees centigrade, the nature of stresses induced are. So here the condition is saying that it is fully restrained. That means this whole lamina is not able to expand from any direction. Or like it is in all the direction it is fully restrained. So whenever there is any stress produced inside this lamina because of this temperature change, it will be it will cause a compression. So it won't be able to expand, and because of restraint, it will cause a compression. And whenever there is a compression, the stresses will be inward and we consider it as a negative. So if it is if it is tensile, then we consider the stresses as positive, and if the stresses are compressive, then we consider it as negative. So as you can visualize it, whenever there is something which you restrain it from for expanding, then it will start getting compressive stresses over it. That's why the stresses in one and two direction will be compressive, which can be said as that sigma 1 is negative as well as sigma 2 is negative. So option D is the correct one. And the easiest thing is when we were also comparing the ultimate tensile stresses, ultimate tensile and compressive stresses, we always took the compressive stress as the negative one, and the positive one was for the tensile one. So here also, as you can see here, the role is by the compressive stresses in the lamina. So the sigma values will be also negative. So any doubts in the questions? Yes, Hari, do you have any doubts?
Yes, ma'am, too much, yes.
Anuj, do you have any doubts?
No, ma'am.
Did you solve the assignment?
Yes, ma'am.
Okay.
Ma'am, in terms of 0 to 90,
Huh?
epoxy laminate, um, it was subjected to longitudinal tensile mode. Ma'am. Am I right? Right. It was subjected to 90-degree.
It was subjected for
Uh,
0 degree
lamina
longitudinal.
will fall for 0 degree longitudinal laminar tensile mode. Yeah, ma'am. 0 degree lamina longitudinal tensile mode. Ma'am, in the ABBD matrix, we have shown it was A26 comes 0 and also A16 also 0. Am I right, ma'am?
It is just 0 and what?
A16, A16.
Yeah, A16 is also equal to 0. So this will also be like a balanced matrix, right? Because 0 and 90 plus minus
Yes.
it doesn't matter. So anything which will be balanced also has A16, A26 equal to 0.
Okay.
But also like this question you can directly solve for the matrix and also see that A16, A26 values are also 0.
Okay. Okay. So when subject to identical slacks, if these directions like this, ma'am, then the tensile load will be
So what you wrote, these two laminates are subjected to same axial tensile load, like sorry, tensile load.
yes, ma'am. Yes,
So
ma'am.
you can,
Then tensile load. Then the strain and those will be.
will be see. First thing you
They
see
ask
that
in
list,
question about.
huh?
Yes, ma'am. First thing we need to remove the.
This question you're talking about, it is like that. What you asked is
Yes,
same.
ma'am.
So see the A
Ah,
matrix
yes, yes,
for
ma'am. Yes.
both of them are same. So that's why when you relate the load with the strains, if A matrix same, load is same, the strain value will also be same for both of these laminates.
Max hello. Okay, okay. It was exact question what they were asking us. They must. Ma'am, also for this unidirection epoxy, then and tau 1 and tau will be both will be negative, ma'am. We are right.
Yes, because it is said that it is fully restrained. So when it is fully restrained, with the temperature raised, there will be some strain and stresses. But if it is restrained, then the stresses will be in the opposite direction, which will cause the compression. So whenever we talk
Ma'am, yes,
about
ma'am.
compression,
What I doubt is if it is fully restrained, when it is
yeah,
fully restrained, when the temperature is raised, the both will be negative, right, ma'am? Yeah.
yeah, because compressive strength will action, and when compression happens, we take the stresses in negative direction. It's like the last question that I discussed. This one, the same concept.
Ma'am, here there is any changes in the diagram? There is any changes in temperatures also? They will be written the same, ma'am.
Yeah, any temperature change, there will be. They are not talking about the value. They are just saying whether it is a negative positive. So value of the temperature change won't matter.
Okay, ma'am. Ma'am, also problem number 6. There is that table column which you have shown.
Yeah,
The previous one.
this one.
Yeah, ma'am. Ma'am, yes, ma'am, this one. Mm, but in assignment, they have given only two plays, ma'am, that we understand. Um in terms of, uh, they're asking the same NX.
What
From
are they
here,
asking?
why we have taken, they're asking the same, like the failure occurs on NX.
Okay, okay.
Failure, the same they have asked, ma'am. But what is my doubt is why we have taken the 90 degrees, the 90 play or the SR2, ma'am. Why not we taken SR1?
Because SR, you have to, the one which will have higher SR will be the one which will fail first. That's why. So you see all the
Higher
values.
SR will failure one. Yeah, yeah, right. Yeah, yeah, right. Yeah, ma'am.
Here it is.
But
10 to the power minus 0.06. So it is also less. So among all four, you see this is the highest one, 0.00059. So whichever will give you SR highest will fail first, and that you have to consider to get the first ply failure load.
Okay, ma'am. Here in assignment question, they have given everything like the same table column, and they given SR2, but in terms of N of X, they have given 100, ma'am, instead of we have given 400. So we can directly solve this, ma'am. 400 divided by this SR2 like that. Here also SR2 will be higher, ma'am.
Uh, SR2 will be higher in the one given in assignment. I'm not understanding your question.
Yes, yes, ma'am. In question number in assignment question also SR2 will be higher. Here the data are same, ma'am. Can we take directly NFX or NFX into SR2?
N of X you can take for SR2 if SR2 value is highest. That's what here SR2 value was highest, so we took NX for SR2. If you solve for your assignment, I don't know if the initial values of the Q matrix and all these matrix or everything is same, then it will be solved into like this only. But check once. Don't like
No, no,
see what are the initial
ma'am.
value.
Other terms,
Like the Q matrix is same also,
yeah, ma'am. Q matrix same.
and this ultimate values are also same.
Q
Different
matrix.
parameters.
Yes, ma'am. Everything was in. The only thing they have given NFX is equal to 400, ma'am.
Okay. Yeah, so for 400, the SR2 value till there it will be same. For first ply failure load, it will be 400 divided by this value if everything else is same.
400 divided by it is 0.02. Second SR 90 is SR2 only. Yeah.
Yeah.
Ma'am, also the failure occurs due to first play. It comes under zero and longitudinal tensile, ma'am. Next page, ma'am. Page number 8.
Which one?
Ma'am, I'm asking about the no, ma'am. Next one. Next, ma'am. Next, ma'am.
This one?
No, no. I mean, question they have asked like this, ma'am. From the table, they have given a table. The
Oh yeah, this one. It's like here in the table you can see the failure mode. So failure mode, like for each angle, like for 0 degree theta lamina, you can see compare the SR1 and SR2, and if you see which one is higher value, so the failure mode will be that one. So 0.00031 it is higher. So failure mode is in 1, and one is in longitudinal. So one always will be longitudinal and two will be the transverse. Uh, huh. Two will be in transverse. So what you are saying in the question? So you will know which angled pi will be in which mode. Mode will be either longitudinal or transverse. One will be longitudinal, two will be in transverse.
I'm not understanding. It will comes under for SR with the value of SR1, right, ma'am?
Yeah. So SR1 is
SR1,
longitudinal.
mm, yes, SR1 is longitudinal. Here SR1 is lesser than SR1 is lesser, ma'am. SR2 only will be higher.
Okay. So whichever will be the higher one will be the one which we have to consider for failure. So 2 is the higher one. Then it will be transverse mode.
Okay.
Okay, so any more doubts? Anyone? Hari, do you have any more doubts?
Ma'am,
Yes.
yes, ma'am.
Do you
Ma'am,
have
a
any doubts?
question unidirectional epoxy lamina, expansion coefficient like that something, and thermal expansion coefficient like 40 micrometer respectively. The induced, the stress induced in the lamina when the lamina is fully restrained and subjected to temperature, something more, this is 100 degree. Then the sigma 1 and sigma 2 is what happened, ma'am? Is positive or negative, ma'am?
Okay, so the last question that I discussed, it's
Both
like this.
negative, both negative. Yeah. Mm.
Yeah, because see, the
Both
thing
negative.
is,
How?
if it is set fully restrained, then whenever there is a temperature change, there will be some strain happening and some stress will occur. But because it is fully restrained, so the stress will be towards inside. So that will cause as a compression. And when there is a compressive stress, then we consider it as negative. So that's why here, whenever you will see the condition of fully restrained, don't matter what is the degree of temperature change, any temperature change will cause some strain and stresses, and because of restraint, it won't act in longitudinal, it will not act in tensile, it will go compressive. And whenever there is compressive, it will be negative. So here sigma 1, sigma 2 both will be negative.
Both negative, ma'am.
Yes.
Okay, ma'am.
But
Okay,
see,
ma'am.
don't
Thank you.
always think it will be that same answer. Suppose it says that restraint is only in y direction, not in x direction. Then at one, then sigma 1 and sigma 2, one of the values will be positive, another will be negative. So you have to see what is the condition of restraining. Accordingly, you have to think what will be the value of sigma. Okay.
Ma'am, if in the question the only sigma x is constrained and y direction is not constrained, okay, then sigma x is,
So whichever will be
negative.
constrained, that will be
I
negative.
mean,
Which will be open, that will be positive.
okay, ma'am.
Yeah.
Okay.
Anything else? Any doubts? Sashi, do you have any doubt?
No, ma'am.
Okay, okay then. I will end the session here. Thank you.
Thank you, ma'am.
Thank you, ma'am.
You're welcome.